Okay, we're going to be looking at a couple of power reducing formulas to be able to integrate some functions. And these power reducing formulas, if you look in a table of integrals, will help you, kind of reduce powers of sines, tangents, and things like that. So we're going to take a look at two examples here, one of a sine and one of a tangent, and we're going to integrate. So this is kind of a repetitive process, and you repeat this until you break it down to something that's very simple for you to integrate. So kind of follow along. If you need to, pause, rewind, whatever you have to do to understand what's going on here. But if we look here, we're going to look at a table of integrals, and we're looking at table value number 67 here. And so if I see here, I have sine to the n. Okay, so I'm going to highlight the n, ax. All right, ax. So let's see how that corresponds to our problem here on number 5. So we have n, which is 5, and ax, which corresponds to this 3x. So if I write down what I know first of all that n equal 5, and I know that a equal 3. All right, now that I've got that down, I have enough to start my integration process. So let's see what I have. I'm going to have a negative sine n minus 1, so 5 minus 1 becomes a 4, and then ax, so 3x, and then cosine of ax, which is 3x again, divided by n times a, which is 5 times 3, which is 15. All right, plus n minus 1, so 5 minus 1 is 4, over n, which is 5, multiplied by the integral of sine to the n minus 2 ax. So let's see what that looks like. That's going to be a sine n minus 2, 5 minus 2 is 3, ax is 3x, and then dx. Now, here's what's going on here. This right here that we have, this new integral, we need to power reduce as well. So we're going to power reduce. All right, we're going to apply the formula one more time, but we have a 4/5 that's going to sit on the outside here. But now we're going to follow the power reducing process. So if I look at this one more time, and let me look at another color, I'm going to say now in this case, I'm going to call it n, suppose n2. n2 is 3, and a2 is 3. All right, so I'm going to use those numbers now to fill out my formula. So I'm going to say here, okay, then this is going to be sine of n minus 1, and it's actually negative sign, right? Negative sine n minus 1, so that's 3 minus 1, so sine squared of ax, so 3x, and then cosine of 3x, okay, divided by na, which is 3 times 3, which is 9. All right, plus n minus 1, so it's going to be 3 minus 1, which is 2 over 3, times the integral, and then we have sine n minus 2, so it's going to be another sine, but in this case 3 minus 2 is 1, so just sine to the first power, ax, so sine of 3x dx. Now we're ready to close off this square bracket. Now this last one is not by any means a power reducing integral that we need to use, but it is a basic u substitution. We're going to say that u equals 3x, so this right here is u, and then we're going to say then that du is going to be 3 dx. So we're going to need a 3 here, okay, and then we're going to need a 1/3 to compensate for putting in that 3. So this 3 dx right there represents du, and now what we do is we just integrate this. So 1/3 times 2/3 is 2/9. So we have a 2/9 there. And then we're going to have what? Let's see, the integral of sine being negative the cosine. So negative, that makes that negative, negative the cosine of 3x. All right, and then of course plus c you could put on the outside there. It's not a big deal. All right, so now what we're left with is we've got to look and see, well, what do I need for my answer? Well, I definitely need this. All right, I definitely need this right here, And I definitely need, and I'm going to put it in a green color, 4/5 times this thing right here. Okay, so let's take a look and see what that looks like when I put it all together. All right, so this is going to be a negative sign to the 4th power, 3x. All right, cosine 3x divided by 15 plus 4/5 times a negative 1/9 rather, is going to be a negative 4 out of 45. Okay, and then I have sine squared 3x, cosine 3x. Okay, and then I have a the negative 2/9 multiplied by the 4/5 is going to be a negative 8/45, so minus 8 out of 45. And then, of course, cosine of 3x plus c, my constant of integration. And there's really nothing more to that. I mean, that's about as good as it's going to get here. All right, so using that one power reducing formula. So let's go ahead and take a look at one last example of a tangent power reducing formula. Okay, so this one is going to be using a power of tangent, integral of the power of a tangent. And we're going to be using this table of integrals formula number 93. So again, the important thing to note is what it is we're dealing with. We have an n, which in our case is going to be 5, and an ax, which in this case corresponds to this 4x. So we write that down. We say n equal 5, okay, and a equal 4. And we're going to use this information to power reduce the tangent there. So the integral works out and evaluates to be something like this. Tangent to the power 4, because n minus 1 is 4. 5 minus 1 is 4. And then ax, which is going to be 4x, over a times n minus 1. So I'm just going to write that out. 4 times 4 minus 1, which is 4 times 5 minus 1 rather. 5 minus 1 being 4. There we go. Minus another integral. And this is power reducing that tangent to the 5th by subtracting 2. So this becomes a tangent. 5 minus 2 is 3. So we're going to write 3 here. Oops, I lost my pen sensitivity. Give me 1 second. There we go. Tangent cubed of 4x dx. Looks just like that. Now we have yet again another power reducing thing that we've got to do here. So I'm going to take a look and analyze this right here. All right, we're going to have a negative on the outside, of course. And then on the inside, we're going to say, okay, well, this isn't too bad. N equals 3 and a equals 4. All right, and we followed the same process basically that we just applied. All right, so let's see what that looks like. So we're going to have a tangent, and then we're going to say 3 minus 1, which is 2, so tangent squared of ax, so 4x, over a, okay, so we're going to say a, which was in our case 4 times n minus 1, 3 minus 1 is 2, minus, okay, and then we have, let's see here, what is the next part of this? The integral of tangent, okay, and it's n minus 2, so 3 minus 2, which is 1, so just a regular tangent, ax, which in this case is still 4x dx. And now we've reduced this to something a little bit easier, all right? And so what we're going to do is we're going to look on our table of integrals for something for tangent. So let me go ahead and look that up and write that down for you. Okay, so here it is. This right here represents the number 89, the integral that we're going to use for this tangent of 4x. So it's going to be, of course, negative in the front. And then we're going to write in what we know. And that is that we're going to say if a equals 4, we fill in the rest, 1 over 4 natural log of the secant, okay, the secant of 4x plus c. All right, so now that we've got all of that together, okay, now that we've got all of that together, we are ready to move along. Okay, we're ready to move this along. All right, and let's see what we get here. All right, we put it all together. And let's see, I know I'm going to need this. All right, I know I'm going to need this. And I know that this negative sign also applies to this negative that sits right there. That's going to change the sign on that. All right, let's see what we get. We get a tangent to the fourth power of 4x over 4 times 4, which is 16, minus a tangent to 4x over 8 times 2. I'm sorry, 4 times 2, which is 8. I'm jumping the gun there. All right, we have a negative and a negative, so this looks like it should be positive 1/4 times the natural log of the absolute value of the secant of 4x plus c. All right, and I think that's about all there is to this. And so we have reached our answer. We've integrated that tangent to the fifth power of 4x with some power reducing formulas. So really, again, the trick is using that table of integrals. It comes in handy and helps power reduce. All right, I have another video on table of integrals that you might also want to check out, because there's just different formulas that you can utilize to simplify the process of integration. So as always, I hope this video was helpful, and remember, like and subscribe.